So hello everyone, I'm Oliver from Cortex Colliders, and we worked with TELMA AI on a project regarding a natural language interface to their Voicebot Creation software, TELMA. So firstly, I would like to introduce the problematics of programming in general. Imagine being in a foreign country where only a small percentage of the people there speak the languages that you do. Imagine having to go through complex business transactions and legal proceedings, or even just daily life. It seems almost impossible, or at least excruciatingly difficult at the very least. Now, this is very much akin to the world of programming for non-technical workers and non-technical personnel. We've identified a number of key industries where we believe that the divide between technical and non-technical personnel is the greatest, since programming in its current state is very much inaccessible to non-technical users and for people without extensive technical backgrounds. So the industries are as follows. We mainly did this on the basis of our previous work experience. So we believe that this would have application in banking, user web automation, and CRM services as well. Now, how do you make programming as simple as speaking your natural language and decrease the friction between a non-technical user interacting with a program? Well, for us, the solution is as follows. We will have a natural language input, and which will then generate a UML diagram, which is a much higher form of abstraction and is easier to learn and understand for non-technical users. And that can be then transcribed into a number of technical or number of programming languages, as has already been done. Now, for the user experience itself, we're looking at two approaches. So the first one is a sort of node selection mode, where this would represent a UML diagram, and the user would manually highlight what parts of the UML diagram or graph in general need to be manipulated and then input a prompt. So effectively, the model managing the graph would have minimized the amount of contextual information needed in order to make a change or any sort of attunement of this graph. So that's our first variation of the user experience. The second one is a more traditional approach. It would be a simple text prompt with continual feedback from the managing large language model, where the user would input what they want to do, and then the large language model would infer which parts of the graph needs to be edited and how. So this is one instance of this happening. So it would automatically infer and edit the graph. Now onto the process of generating the graph and managing it itself. We're looking at, in this example, to give you a more visual understanding of the process. So in this case, we're looking at a restaurant reservation bot. So this relates to the topic of Voicebot creation in general, as TELMA does, our company. So we have a user prompt, which is then stratified, as we say, or effectively the prompt is broken down into individual logistically or logically rather independent components, which can then themselves be turned into subgraphs. So firstly, you generate the instruction set effectively for the large language model, and then based on these, you generate the subgraphs individually for each stratified task. Then our vision for this is to also have implemented two forms of error checking. So the first one would be, well, regular compilation time errors. So if the UML diagram is plain wrong, well then obviously you want to highlight that to the user. But also, since the graph is managed by a large language model that has contextual understanding of the graph, we could then also highlight parts of the graph that would need reorganization or perhaps some subtle edits in order to better fit the vision as described by the user. So moving on to graph minimalization, which is a broad range of techniques that help improve the performance of graphs or reduce the number of vertices depending on some input parameters. So in the case of UML code, we would, for instance, either be minimizing the number of blocks, which would likely correlate to better performance, or focus on performance itself. So minimalization in this context could also mean adding some as well. Now, lastly, we have consolidation, where all the subgraphs that have thus far been independently managed come together to form a final graph, a consolidated one, that effectively contains all the instructions that need be done. So, and lastly, of course, we visualize it to the user in the form of, well, a diagram. So that's that. Now, where does TELMA stand in all of this? Now, TELMA is a chat and voicebot creation company. Well, they rather provide the software for this. They provide CRM solutions, and they have given us API access into their software so that we could integrate our vision within the bounds of their product. Additionally, their target customer base is non-technical, so that fits very well with our criteria as well. So, and we will show a live demonstration of working with the TELMA's API and generating a graph for you here live. So, carrying on, what we would need to do in order to finish this vision and finalize this project would be to have Turing-complete UML diagrams. So effectively, we would need to create a library or license some of these UML to code programs, where we would have generic blocks, they would be logically independent, and all of that, along with some of the graph optimization techniques that we've already mentioned. Now, from the business point of view, how we would be looking to commercialize this is we're basing this off of Patrick's, one of our team members, work experience in banking, and where he has identified a potentially lucrative niche for this concept to be applied, where we're looking at database mappings, so effectively just defining relations and making them transfer in between databases. So obviously, in the case of a bank, this is highly sensitive and is managed by experienced professionals, and this would help effectively lower the barrier of entry for non-technical users and overall management as well to understand these procedures and therefore help improve the cost, will reduce it, and as well as perhaps the performance of these mappings. So, and lastly, from the technological point of view, what we currently don't have implemented and what we're looking at, what we're looking to implement is that we would either fine-tune or create our own LLM that is specifically tailored for text-to-graph applications, or create or just sort of adjust an existing one. Like right now, we're using GPT-4 Preview that is able to generate JSON, so that could work as well. And then we would need to either implement our own bespoke UML to code language, or we could license, as already mentioned, from projects that have already been done. And then additionally, we need to implement the error checking, minimalization, and consolidation techniques as well, along with the abstraction of non-business concerns in the UML. So for instance, logging and security and things like that. Now for the live demo, I'd like to show you a video of how our system works. So, can you see it? Excellent. Yeah, so now you can see the existing graph that has been created by the user. The user enters a prompt, which in this case would be, well, Silly Goose Orthodontics Reservation. So that's the name of the orthodontics office. And they would like to create a reservation bot for automatically managing reservations. Now, OpenAI's API processes this and generates us a graph which is then shown here through the CMB, and then finally through this. So this is the final product. Thank you very much. Thank you for your attention.
Thank you very much. I'm inviting human-generated questions, please.
Very well. Patrick, can you get the mic?
Hey, thank you very much. I really like your project. This looks like a great deal of work. I wanted to ask you, could you be able to describe a bit the impact of what you've done? It looks really cool.
Well, the impact of what we've done currently is that we're able to take effectively almost any prompt and create a conversation bot for it using all of TELMA's modules, including simple branching conversations. So for instance, here you can see that there are open questions, but there's also a binary question, whether or not the person is a returning patient. So our model is also able to manage branching within the conversation and map the graph effectively to fit that description. So yeah.
Okay, I'm very interested in the demo because I think you skipped around because of time reasons. Could you show the input that created this graph? Like, what was the description?
What was the
Like,
prompt?
Yeah, prompt, yeah.
Sure. It was Silly Goose orthodontics reservation bot.
And that's the whole prompt?
Yeah. Yes,
oh, okay.
Correct.
Thank you.
Yes, here we have a question from the expert.
Okay, looks pretty cool. Thank you. Have you tried like different prompts? What are your feelings about like where it fails, where it works? For example, like, can you tell more about your experience with your own tool, actually?
Yeah. So we were surprised at how well effectively it manages to do on conversations that don't require much branching. So for instance, with the binary questions, when there aren't many yes or no's, which result in, you know, sub-branching and stuff like that, it works excellent. But when it gets over one, it like the model, because we're using ChatGPT-4, it's not exactly like best suited for text-to-graph operations. So there is some errors once we get a lot of branching depth.
Yeah,
Thank you.
I just want to add to this that we don't have implemented the stratification. So the context is like whole, and it doesn't have a single purpose for the subgraph.
Thank you. Thank you.
Are there any other questions? If not, then let's give a big round of applause for Cortex Colliders.